Hello everyone. I hope you had a fun time today, and I also hope you will have okay time with me here today. I want to talk about cloud security today, and especially from hackers' point of view. But before I dig deeper into the topic, I want to introduce myself. So my name is Kankaala, and I am from Finland. I work as a security researcher at Detectify. And back in Finland, I also have other kinds of projects going on. For example, we made a documentary series about hacking with the Finnish national TV channel. We have 6 episodes. In those 6 episodes, we hack into different kind of things. We have a YouTuber whose life we hack into, IoT devices, a car, Wi-Fi, and so on. So those are unfortunately in the cryptic language of Finnish, but if you're interested, you can find them also online. And especially the YouTuber's life, it's on YouTube and it's subtitled in English. In addition to that, I'm in the board of members for a hacker event in Helsinki called Disobey. And I don't know how many of you have heard of Disobey before? Okay, cool. So it's a hacker event, takes place in Helsinki during Valentine's Day. So you get to meet all your hacker friends there. Also, like work-wise, I have worked as a pen tester for a couple of years, and on the side as an incident responder, red teamer, and before that, I used to also be on the other side of the table. So I was a developer, or more like a sysadmin, to be honest, but did some coding on the side. But already back then, I got an introduction to cloud infrastructure and cloud services, and that's why it has become my basically like a pet child of mine. And today, I want to basically go through the history of why we are here. And I want to take myself as an example for this history lesson today. Also, I want to talk about what do hackers see, or what do security researchers see on the outside when it comes to cloud security. And after that, I want to try to answer the question of what do actually hackers want in cloud infrastructure. So to start off, I want to take you back all the way to the good old 90s. So this picture is from 1996, and we have just gotten our first computer. I'm the one sitting on the computer, and my little sister is waiting for her turn, like pulling me and asking me to let her play video games. And that was what I did back then. So I loved playing video games. I played them so much. I had this one favorite game called Jack Jazz-Rabbit. How many of you have played it? Oh, cool. Okay. 2 people. But it was basically a platformer. But I used to play it so much that I would get epileptic seizures, and my mother had to manhandle me out of the computer, or away from the computer. And it was it was tough time. And also with my father, we used to build computers, and I used to basically grow up with computers. And I did my first website around, it was early 2000. So I used a service called GeoCities to do that. And it's I think most of you have heard of it before. It was basically the go-to hosting platform for your website. And back then, arguably the overall infrastructure behind things, so the servers and everything, it wasn't that extensive. Also because the use of internet was not that extensive. So we had a higher, or the barrier to use the internet was a tiny bit higher. Also because you needed to have, for one, your own website if you wanted to be part of an internet community. And then back then, internet was not that searchable. There were search engines, but they were not that optimized. So you needed to really know what to look for back in the day. So that's why you would either use, GeoCities, or there was free webs and all kinds of these external services to host your websites, or then you would have your own server somewhere locked in a closet. And even back then, this early 2000, my first interaction with hacking was that my friend's website got hacked. Naturally, it was also hosted in GeoCities. And they just took the website and changed the wallpaper on the website. And I was like, what? This is so crazy. Is this hacking? And it was the first time I encountered, and first time I actually realized that some people do this. And back then, it was for fun mostly. you pranked your friend or something like this. But coming to this day, we are using more and more cloud. So back in 2000, like as I said, we had our own websites, but nowadays the data is more centralized and the services we use are more centralized. So we have social media. It's easy to use the internet. Google is really good. It already knows what we want to look for before we even use them. So that's why we use cloud services. They provide a scalable infrastructure for a big platform, a big service provider to provide a lot of content to a lot of people. And with that, even though we still use traditional data centers, but it's interesting to think of the differences between what you would call a traditional data center and a cloud service provider. Because with traditional data centers, you necessarily didn't even see what kind of servers you were running, how were they operated, and then you had these great firewalls blocking traffic, and the perimeter between your servers and the internet was more clear. Or maybe you didn't even have to worry about it because someone else took care of it. But now that we have cloud services, we have more visibility into the configurations of the servers of the platform that we are actually using. And it's served to us by virtualization. So it's brought to us by these service providers. And what this means that we are no longer just dabbling with static IP addresses, for example, or static public IP addresses. We have URLs, we have resource names that can be routable to the internet. And it can be sometimes hard to understand, is this application now, is it in my internal network, or is it actually somewhere and someone can find it on Shodan? But I'll go back to that in a while. And I have heard this thrown around a lot. Not that much any longer, I would say, but the fact that cloud is just someone else's computer. And this is typically said in a very negative context. So I would argue that everything has always been someone else's computer, unless it was the computer in your closet. But even in that case, there's always trust involved in when you run something in the cloud, or when you run something in the traditional data center, you always have to trust that the hardware is secured. Or if you don't trust it, then apply some other mechanisms for protecting your data. But today I want to focus more on the hackers, and not the hackers that go into the data centers and leave their network implants, but those who are basically like me, and they don't want to go outside. So what they can actually see on the outside, and how can what can be seen on the outside then used against the company or against these systems. So there are basically three big players in cloud service world today. So there's AWS, there's Azure, and there's Google Cloud Platform. And while there are others, these three are basically taking, or they have the majority of the people or the users that are using cloud services. And I have examples today, and most of them are very cloud agnostic, so they will apply to all of these services. But some of them not so. So I will always tell you, is this cloud agnostic, or will this only be related to certain service? But I just want to point out here that when we talk about these cloud services, the use cases for these cloud services is typically quite different. For example, AWS is typically used to host something, application, system, either serverlessly or basically just hosting platform or infrastructure as a service. Azure, on the other hand, with combination of other Microsoft products, is used more for end users. So you provide, for example, Outlook, SharePoint, and stuff like this. So it's more heavily focused on the you have end users using your platform. And Google Cloud Platform was basically built around Kubernetes at the time, and now it has most of the same kind of services that AWS has, for example. And I mentioned that I also worked as an incident responder. So I want to highlight that there are, when we start to use something new, our new way of hosting things, there will be incidents involved. So hackers will be interested, especially in these kind of environments that are the perimeter is not that clear. So if something is exposed to the internet, there will be incidents. So I want to just briefly touch upon a couple of incidents. And these are by no means unique, and this could happen basically to any company. But I was dealing with this one case that had AWS accounts. They were hosting a lot of stuff in AWS. And they had an accident where one of their external personnel pushed their whole source code of their application to a public GitHub. So what happened then is that if you have used AWS, you know that the AWS key, it always starts with AKIA and also I at the end. So it's super easy to fingerprint. So if you push these to any public repository, for example in GitHub, there will be bots that are crawling for these keys. So in some hours, their AWS account was used to host a lot of crypto miners. So basically what they did was they accessed the AWS using these keys and then launched a lot of new EC2 instances or the server instances there with a lot of computing power and made some money with that. And that is I think this is even though this is one specific case, with AWS, this is no means unique that AWS keys leak one way or another, and then they end up being used in this similar manner. And the short lessons learned from here is that AWS keys, because they are so easily fingerprintable and they are so lucrative for the attacker, it's better not to ever store them in the source code, even if you think that the source code is in your control, because you never know where the source code may actually end up when it's cloned by your worker, your own employees, or your whoever's working with you. And then this one is related to Azure, and actually I've dealt with a couple of these cases, so that if you're using Azure, and you are using, for example, the O365 suite, so you have the Outlook there, you have SharePoint and so on, you are basically exposing this kind of a login portal, one way or another. So this is, for example, a company's login portal. And then if you have an opportunistic hacker who wants to put tiny bit more effort into the hack, what they will do is that they will go on LinkedIn and try to add you or someone from your company. And after they've added you, they get access to your second degree contacts. So basically they can see everyone who's working for you. They will take that name list and they will go on these login portals and try all of those email combinations with a handful of passwords. And when you are talking about huge corporations that are have active directories or ADs that contain hundreds of thousands of users, there is the chances of someone using a weak password goes up. And when you get into someone's email through these portals, naturally you get access to the emails, but a lot of the cases, it also resulted in phishing from the inside. So these are actually then just the first way of gaining more credibility to the phishing campaign that they are using when they're sending emails from inside the company. And not only that, but with Active Directory, if you have it on the cloud, if anyone using the Outlook, for example, if their entry is in the AD, that is in Azure, they can by default logging into the Azure portal. And what this means is that they can gain access to the whole AD hosted in that Azure instance. You don't get access to the NTLM hashes, which is good, but what you can get your hand on is the overall, how is the domain forest built? So what kind of users you have, what kind of groups they belong to. So let's say you have access to someone's email, you know then, okay, this person is in the admin group. I want to target that person more heavily with the phishing attack. So with this like Azure environment, it's a tiny bit harder because you want to host your AD there and you want to serve you want to have people being able to access emails and do their basically job. But for that, basically just having good password policies, and not only that, but MFA enabled, it reduces the amount of these hacks happening. Or they can try them, but then they will need to figure out how to get the MFA token as well. By the way, if you have any questions at any point, please do ask, because we are quite like an intimate bunch here. So I don't mind answering any questions, and especially like if I'm using words that are like, you don't know, or if I'm not being clear with something, or my Finnish accent is too strong, then please let me know. But when it comes to tackling security in cloud, I'll just shortly touch upon this. But for example, AWS, they have this approach, or they promote this approach of security by design. So what it means basically is that you have everything automated. You have your security control streamlined, so you can automate patching, automate security detections, and so on. And it makes sense if you're hosting applications or hosting software. But for Azure, the approach is more on the assume a breach side. Just because of the reasons that I just told you, you have a lot of users, and in the end, how much can you then cover with just automatic controls? You need to be able to monitor, you need to be able to respond fast to incidents. But a hacker doesn't care about any of these controls. They just, if they're an opportunistic hacker, they just want to find what is the most low-hanging fruit they can use to get inside an environment. So, going to the actual topic today, it is, as I said, tiny bit hard to understand what you are exposing sometimes to the internet. Even though, for example, AWS typically, or all of these service providers, they typically go the extra mile of telling you, okay, this is now exposed to the internet. Are you sure you want to do this? But there are still cases when this is not so. For example, with if you have abandoned subdomains, some of the service providers are very clear if you're deleting, for example, CloudFront instance, or if you're deleting an instance that's pointing to a CNAME, that are you sure you want to delete this, and then also delete your CNAME. But not all of these are very clear, and sometimes they are missing. But with open source intelligence, like what hackers are trying to look for, they're trying to look for these kind of things, the things that you are actually misconfiguring, actually exposing to the internet. So this is like, when it comes to cloud services, finding, for example, subdomains is very interesting, because you can find abandoned subdomains, as I said. So you can register then those subdomains under your own name, or you can point your own instance to that abandoned CNAME. So what you can then do, that let's say that I have a subdomain www.lara.fi, and if I have, basically, I used to have a CloudFront instance there, but I deleted that, then my CNAME still exists in my DNS records for that. So then anyone could basically just go to their own AWS account, go to CloudFront, and start an instance under that CNAME. They have to do some dig searches to see what's the correct name for that CloudFront node. But this is something that is being done quite a bit, especially like, well, this is also coming from the bug bounty circles, but in the worst case scenario, these could be used for phishing domains, having very legitimate phishing domains if you can get someone's subdomain, or if cookies are misconfigured, you could basically steal user cookies or session cookies through that. And not only that, but finding abandoned subdomains is interesting, because they contain a wealth of information, and they contain stuff that was developed way back, but someone forgot to take down, or like stuff that was tested, but then not really wanted to be public, but it kind of like forgot there. So it can provide, like, if you have a main domain, it's typically very secured, but those subdomains can be quite insecure. So how to find these subdomains is basically there's a lot of tools for this, but for example, TLS certificates are good because you can find subject alternative names or SAN names for those from there. So all other domains that are under the same encryption certificate. You can look at DNS history, so what used to be there but may not be there any longer. Then naturally Shodan and going through Google and Wayback Machine. Source code can reveal a lot of information. There's a lot of automated tools. For example, our tool does this as well. So to find what you're actually exposing. And the picture here is an example of domain takeover. So here you basically have a Heroku instance that used to be at x.example.com, but then Heroku instance was deleted and now it's basically up for grabs. And when it comes to open source intelligence, there's like a lot of data you can gather and a lot of data you can handle, and then it's sometimes hard to understand like what is the most interesting to look at. But I wanted to bring up this example of SearchStream, and SearchStream is I think this more talked in like the blue teaming circles or like when you're defending stuff. And SearchStream is a tool made by Calidoc Security, and they are using another third-party tool called Certificate Transparency Log. So Certificate Transparency Log is an initiative put forward after a couple of certificate authorities were compromised, and there was like tiny bit of mistrust towards certificate authorities who are issuing these certificates. So Certificate Transparency Log basically logs every time when a certificate is queried. And the search stream is just a tool that you can use to sit by the stream and watch the stream go. So whenever, let's say someone goes to Google or like a specific, like opens a specific website that has a certificate enabled, it will be logged in here. And when it comes to cloud security, this is an interesting source of information because you could just basically go through this log and look for example, open S3 buckets. So whenever S3 buckets are open, they will also be logged here. And there are tools around, for example, this case, or there's many kinds of tools around this specific search stream utility. But I wanted to bring it here because it's like a very opportunistic way of looking at this. Because typically, for example, the blob storage is S3 or the Windows or Azure blob storage, the names are not public and you cannot find them anywhere. So from these kind of sources, you could find them. And this search stream could, for example, help you bypass web application firewalls or load balancers. If you can find let's say you're hosting your website on a blob storage, and then you can find it here, and then you see that, okay, this should have like a web application firewall in front of it, but then you can just basically bypass that. And also, I mentioned before that we are not dealing with static IP addresses that much any longer, which is true and untrue, because all of these also have public IP addresses most of the time. Not most of the time, but they can have public IP addresses. But what they will have is a resource name for example, EC2 instance. So you could find these from Shodan just by looking for the compute.amazonaws.com is the URL or the resource name that is given to EC2 instances. And not only that, but sometimes you don't need even like big hacks when it comes to cloud security or like cloud stuff. You can look for databases. You can look for other kind of data sources. And only in Shodan, when I searched for MongoDB, I could find 74,000 and more MongoDB instances directly plugged in online. And while I don't know if these have any authentication in front of them, it's still not a good situation if your database is exposed online. So these should be backend services, and it's so easy in a cloud environment to forget that, okay, this may now actually be public. So it's really good to keep in mind that all of your data storages and places where you store data, to check if it's actually exposed online or not. Because, for example, these MongoDB instances that have been left open to the internet have been used in very major breaches just recently. And then when it comes to cloud services, a lot of people are using them to serve web applications. But this brings an interesting topic here, because the way that, for example, AWS works, or also in Google Cloud Platform and in Azure, they have this service called Metadata Service. So Metadata Service is a service that you can query from internal network, and it will return information about the instance itself. So it will return information like what's the host name of the instance, what kind of like security groups or firewall rules, if you will, the instance has, and data like this. But what it also exposes is security credentials or API keys. So it will give out temporary credentials to access AWS account itself. So now you can see where I'm going with this. So if you are somehow able to access this internal service, then it could be a very bad thing for your AWS account in its entirety. And that's why when we have server-side request forgery, so SSRF for short, I would argue that in a cloud environment, even though, for example, Google Cloud Platform and Azure, they implement the metadata service tiny bit differently, they still have that in there. And this is the most easiest to exploit in AWS. But I would say that for hackers, it's for a long time finding, for example, remote code execution or RCE is the crown jewel of vulnerabilities. But in cloud environments, it could be very well just finding a server-side request forgery. Because what this kind of vulnerability, for example, if you have misconfigured your web application firewall, or if there's just a download function in your web application that does not filter what user actually inputs there, you could expose internal services to the world. What this means is that then,
what is your view of the second version of the AWS metadata service that they just released?
That's a good question. Let me answer that in a second. So what you can do with the server-side request forgery is then query the metadata service. And there was a good question from the front row. What do I think of the new metadata service version? So AWS just recently improved their metadata service because of this has been exploited in other cases as well. But one case that got a lot of publicity was Capital One hack. So in that case, there was a person who was able to exploit a web application firewall, and they had a server, they could exploit the server-side request forgery vulnerability there. And they were able to access Capital One's backend servers and exfiltrate a lot of data from there. So what AWS did after that, and what they want to do is naturally make the service better. They introduced a new version of the metadata service. So it will have, in addition, you cannot just send a GET HTTP request to it. You need to send a request before that and stage it basically before it can return any data to you. But the improvement is good, but the only thing is that it is optional as of now because of backward compatibility. So it's not, you can choose to use that instead of this one. But I would say that a lot of companies will probably keep using this, especially if they already have built-in web applications or services that rely on this service. So it may take time for them to actually fix this and start to use the new version of the metadata service. But it's good that there are mitigations in place, but that's why I think server-side request forgery will be, in the near future, it will still be a very relevant issue. And especially if it's combined with something like this. So this is AWS IAM role example. So in all of the cloud services, you have role-based access control. So you have AWS identity and access management, for example. So what this statement basically says is that, okay, this service, you can call this action within the AWS account. In this case, it's attach role policy. And you can call this action to all IAM resources. And I wanted to bring this here also because this was something that I encountered basically in a red teaming assessment. And it enabled me to have a root on the AWS account. And that is because right now with this role, we can add any role to the role that we are now commanding. So basically, we can say just attach role policy administrator, which is AWS default policy to this specific role. So we can bypass any kind of other form of limitation on this specific role definition. And I think it's interesting because having a root on AWS account, it can then look basically like this. And I said in the beginning that I want to try to answer the question of what hackers actually want in the cloud, or what, like, not hackers as in security researchers or white hat hackers, I hope. But I think for hackers, it's basically the same as any other service or any other infrastructure. The only thing is that it can be left misconfigured. It can be left more exposed than, like, maybe easier than a traditional data center database. And also, if you can have access to someone's AWS account, it provides good means of making money for yourself. As I told you, the incident about the AWS, these guys were detected super early because of the proactiveness of the company, but it could take, let's say, a whole month of anyone noticing before the next AWS bill comes along. And you're like, okay, what are we actually doing here? It's quite expensive, our AWS use. And it's just like, there's so many ways of benefiting from it. And also, because of the databases, you can get access potentially to very sensitive data directly from the internet. Yeah, that's basically it. Any questions?
Do you have any?
Yeah, no.
Do you have any opinions about the security preparedness or level of the three main cloud providers?
Of themselves?
Yeah.
Well, yeah. Yeah. So naturally, like when we talk about them, like they employ what we call a shared responsibility model. So whatever you build upon their services, you are basically responsible for that. But then they offer the scalable infrastructure. So they have the data centers, the physical facilities, and those have like audit reports that you can read online. And I assume that if you're a faithful customer of either one of those and spend enough of money, they will probably give you tours and stuff to the data centers. But naturally, like, I think it all comes down to how much can we actually trust our physical infra, or do we have to employ some kind of other mechanisms to protect sensitive operations, such as encryption. But
I'm pretty sure the list of people who have actually gone to see Amazon data centers outside of Amazon is in the low 10s still, and most of them are government clients. But
Yeah. And that I think that they don't let them, for example, poke around with the hardware or anything.
That there is not anybody left, even companies spend billions of dollars with them, just to show that they treat everybody equal. Nobody else will poke around.
Yeah, and that would make sense, absolutely. And yeah, when it comes to hardware, and it's an interesting topic in and of itself, and unfortunately I didn't cover much of it in this presentation, but just the fact that we are always relying on someone to provide the physical hardware for us, unless it's, in our own control. We have our own data center. But even then, there are internal threats. There are like people who want to do bad stuff. So that's why we have mechanisms such as encryption. on hardware level or on the software level, that we can try to mitigate these issues. But I think it's healthy amount of skepticism that we like always think about, like how much can we trust this equipment that we use. Did you have a question?
It was just an opposite. When you were talking about correlating pulling email addresses from LinkedIn, I was going to say there's a tool called Prowler that's really nice.
Yeah, I have used Prowler. Yeah. Yeah, that's for AWS auditing, basically. Oh, no. Or you mean the link? Do you mean crawl? No, it's crawl.
Prowler.
Prowler. Okay, there's a name.
Prowler is an AWS auditing one. That's the most well-known.
Yeah.
Sorry.
Yeah, but for LinkedIn, there's a couple of tools that are available, but sometimes they do not work straight out of the box because LinkedIn keeps changing their layout and they want to prevent this happening. So
no, in fact, I would like to know which tools you use, not for security research, but because I'm trying to get my content out of LinkedIn without having to log in.
Yeah, you need to have a fake account.
Well, no. I have a legitimate account,
yeah,
but I don't want to have to use the UI to look at something and deal with people while looking at saved links. That's all.
Yeah.
So I want to pull that out.
Yeah.
I won't take away too much, but all accesses the global LinkedIn address book that's available, so you don't have to connect to people.
Mm-hmm.
And you provide it with a schema based on some possible assets. So if you know if it's first name dot last name, you can say fn.ln at a domain name, and it will scrape LinkedIn's public address book for anyone like that company and provide you with a list that should work.
Yeah. Okay, I'm not familiar with that tool, but sounds handy.
Connect, I was trying to stick in the nose.
So I can take it back at a bit of the previous question regarding relative security of clouds. In my experience, we're currently working major multi-cloud deployments. Any single cloud provider is easy to be insecure on because they make default configurations available and they're all constantly developing. Most of them are reasonably secure if you figure out what you need to do, but the big challenge is staying up with how beta they are. So a great example is Amazon tends to be a little bit more mature overall, but one of their newer services, EKS, that's their host Kubernetes service, its default puts your API server, which is a key to the kingdom, on the public internet. That's the default configuration for deploying EKS. Theoretically secure because there's still basic auth on it. I'm sure we've just thought about that. But yes, you can change that. That's not a default. That's serious a bad thing. On the other hand, take a platform like Google's, and they're developing it so fast that the GUI and the CLI don't have matching variable names. And that's not documented.
Yeah.
You find it out in practice.
Yeah.
So that's usually where the fault comes in.
Yeah, absolutely.
Similarly, on Azure, you'll find APIs that are really useful for security, that come into the community. Microsoft decides to formalize them, and in the meanwhile, they pull them.
Yeah.
If you get hit while that happens, you're completely blind and you're at the mercy of the Microsoft team. It doesn't matter how large you are, if it's not planned for rollout in your region, you won't get it back. So,
not to mention their logging is.
That's a good point about because these services also, everything is a service, so they introduce new stuff all the time. And then when new stuff comes out, that's actually really interesting for a security researcher because it gives opportunity to look at this new stuff and see what are the defaults and try to improve this early on. But naturally, there are services that are not that much used or are not that attractive to security researchers for one reason or another. So those tend to be then, they are not paid that much attention to. And naturally, these providers, they have their extensive security teams constantly working on these things and trying to figure things out. But I just think that sometimes the external eye pair is more powerful than the internal one, because then you have the creative, you can actually see what you can do then, what's the worst that you can do. And naturally, not to discredit the security teams, because most of the silly stuff is probably already fixed by the launch time. So, yeah.
It's great that you mentioned this shared responsibility, because at the end of the day, it's always the customer's responsibility.
Yeah. Well, unless someone goes into the data center and pulls a plug on you. But even in those cases, I don't know what would happen to your application.
Another way, whether it was the cloud provider or the customer that goes wrong, is the customer that's accounted for.
Yeah, and the customer will, eventually the downtime or whatever happens, it will fall on the customer. The customer will have the downtime and your applications will be affected nonetheless. Awesome questions and awesome input. Any more ideas or questions?
I'm thinking of one-way entrances to data centers now. That sounds like a bad idea.
You're thinking of what?
One-way entrances into data centers.
One-way entrance?
Yes.
Yeah. We'll have to think of something.
I'm pretty sure there's a human link issue with that.
Yeah, probably. Yeah.
I have one more.
Yeah.
What's the funnest thing that you've done? And like, what's maybe a coolest hack or a technique? Something that you really enjoyed?
When it comes to cloud stuff, I would say, well, that exploiting that IAM thing, it was part of like a bigger assessment. That was quite fun. Actually, one thing, this was before like the domain takeovers, subdomain takeovers were that familiar or that like known to like general public or bug bounty hunters. But yeah, well, not the general public, or don't know how security enthusiasts they are, but we had, I was talking about the TV show that we did for that, because it was for the Finnish national TV channel, and we were shooting a pilot, so we were able to compromise their some of their infra through that. So that was interesting, and at the time that was kind of like cool, and like because not that many people were talking about it, so I thought that was fun. Yeah. Anything else, or do you want to kick me off the stage?
No, I don't have to.
You can. Yeah. Okay.
But we're going to have a coffee break. The band are here. They're going to set up in there. So we can reconvene at 4. Last go on the escape room is 2:45. And so we should have some beers and drinks in here when we get back in.
Thank you.